We're going on now to Chapter 2, which will be a review of graphs, equations that are lines, and inequalities. Now, we don't cover in our practice in QuizMe the inequality, but it's so little. These sections are really short, so I will try to include that. And we're going to look into graphs, and I'm going to start off with an extra slide here that's not in the PowerPoint, but I think would be helpful. Okay, what I have on this particular page is some of the formula that you will run into in this chapter 2. Now I've numbered them a little bit so we could use that as a reference later. I'm going to call Formula 1 standard form of the linear equation in two variables, x and y. I'm going to call Formula 2 the slope-intercept formula, and we'll be using these, where m is the slope and b is your y-intercept. It's where a line will cross the y-axis. This is the slope formula where if you have two ordered pairs, x sub 1 comma x, or I should say y sub 1, and then another ordered pair, x sub 2 minus y sub 2. You put it in this formula and it determines the slope of the line, and we'll be working on that in this section as well. I don't see that you've used what I use 4 as a reference for, but 5 is used. This is y equals b, and y equals b by definition is a horizontal line going through the y-axis. Remember we said b was the y-intercept, going through that point on the y-axis. And then another one similar is, I call it Formula 6, x equals a, and it's a vertical line going through point A, which would be your x-intercept over here. So a little refresher on the graphing system we use. We have an x-axis, which is horizontal, which is in a sense a number line. To the right of the intersection here, these are positive. Here, these are negative. Then another number line, this time vertical, where 0 is right there at the intersection. Above is positive, below is negative, and it makes the plane divided into 4 regions, which are called quadrants. So this is the first, the second, the third, the fourth. Now in a course that was teaching this, instead of just a quick review, there's lots of stuff here, but for right now we'll use that. And as we've already mentioned, when you draw a line and that line crosses an axis right there, that's called the y-intercept. And where it crosses the x-axis, that is called the x-intercept. Now, one of the techniques I like to present to the students is when you are going to do a graph, and let's say it's in standard form, you make a special t-chart and you put a 0 in this spot under the x and in this spot under the y. When x is 0, whatever value you have there, that's going to be your y-intercept. When y is 0, notice that's what it is right there. Y is 0. Whatever's going to be there will be your x-intercept. So this is a special t-chart for finding values, and we may use that in the next slide. So we're starting in the official slides of the PowerPoint, where they're asking us to sketch the graph of this equation. Now, generally, when you have something like this, the strategy is to make a little t-chart. And usually we like to get 3 points. And the points we like to get are toward the origin, whose coordinates are 0, 0. So if we choose for x, let's say a -1, a 0, and a 1, it's going to be right around the origin where we make our graph. So if x is a -1, a -2 times a -1 is a +2, plus 5 is going to be 7. If x is a 0, this 0 here, a -2 times 0 is 0, so this just becomes a 5. Now you'll notice this is our y-intercept here, where the 5 is in a sense the letter B that we just mentioned. And by the way, this was formula 2. This is in slope-intercept form. And if x is going to be a 1, it's a -2 times 1 makes it a -2, and a +5 gives me a 3. So I'm going to graph that. So I made a little graph here of the points that I'm going to need. I need a -1 here as well. So I go -1 for x. So I'm going to go from here over 1. And then I need to go up to 7 right there. Then I go 0, 5. So there's 0. Going to go up to 5, which is right there. Then I'm going to do a 1 and a 3. So there's a 1 and there's a 3 right there. Now notice my points are in a straight line, and I have a line tool. And in a sense, that's the graph of that line. Now, are there other coordinates along this line? And the answer is yes. There's an infinite number of coordinates. So we indicate that by putting an arrow on each end, indicating that goes on to infinity in that direction and then infinity in this direction. Now, when they say sketch the graph, this is what I've done. I've sketched it. I didn't have graph paper. Fortunately, on your practice and quiz me and test, you will have graph paper as part of where you put the answer. But there is another way to do this as well. Let me show it to you. Again, this is meant just to be a review. We're not trying to teach it, but maybe rekindle it if it's somewhere in the back of your mind. Now, when an equation is in form 2 here, slope-intercept, we said that what is the coefficient of x right there is actually the slope of this equation. And what is in the B position, that's your y-intercept. So another way, and sort of a shortcut way of graphing it when it's in this form, equation 2, slope-intercept, is you put a dot at the y-intercept right here at 5. So that's right there. Now, slope, we said, which is m, and we'll go over this a little bit later, is actually a ratio of y units to x units. So what is that? Well, it's a negative 2 over 1. Even though there's no 1 under the 2, there is 1 there. There's always a 1 under any number. We just don't write it. So what does that mean? Well, it means, and then, by the way, this is rise, that would be the x units, over run, which are your y units are the rise, x units are the run. So it's negative, and I show my students that if it's a negative run, you go over 1, and then you do your rise of 2. And notice, that's it right there, over 1, up 2. See, there's your slope right there. And then, from that point, you make your line. And it's the same graph. So, what we're showing you then is 2 ways to sketch this graph. Making a T-chart, or using knowledge of doing it from the slope-intercept form. And again, we're not teaching it, but I do have other videos that show this in much more detail in Math 1103. So in the official slide, they do show a T-chart where they have more than 3 points. Notice there's an infinite number of points along this line. The line is infinite in both directions, and some of the key things, of course, is where it will cross the y-axis. 0, b is your y-intercept. And there it is. Okay. Now, here they're reviewing this concept, which are the intercepts. And once again, I will draw that for you. This T-chart is very useful. I call it the X and Y intercept T-chart. So if X is 0, whatever is at B is the Y-intercept. If Y is 0, whatever is at A is the X-intercept. Okay, we're going to take a look now already in section 2.2, equations of a line. Now, this was the formula 3 that I mentioned in that first slide, where we're talking M is the letter we use for slope, and it would be change in y units over change in x units, which is rise over run. Now here they want us to find the slope of a line through these points. So as we do this, there's our little formula. Our y sub 2 is 4. Our y sub 1 is 8, so 4 minus 8. Our x sub 2 is 5. Now notice there's a minus in the formula, and the x sub 1 is a negative 6. So I put it in parentheses because here's a case where we have the opposite of a negative. Now whenever you see this arrangement, as we mentioned before, we just make it positive. So it's two negatives make this the positive. So we have then in our numerator a negative 4, and in our denominator an 11. So our slope here will be a negative 4/11. Remember, we're allowed to put that negative sign anywhere we want of 3 positions, but the best is at the division bar. And there it is. Notice if you have printing, it's really nice and formal there. Okay, a couple of special things, and I'll set this up. Now, earlier we had mentioned a special formula, calling it number 5, y equals b. Now, we had said that b was the y-intercept, and they're giving us the equation then to graph y equals 3, let's say. Well, when we go to do that, this is going to be a horizontal line through 3, its y-intercept. And going on to this one for a moment, x equals a, that was the x-intercept. That's going to be a vertical line going through -2. Again, it's the x-intercept. Now, some special things about this is, what is the slope of this horizontal line, this formula? And the answer always will be the slope of a horizontal line is 0. And if you did it in the slope formula, it would end up something like m equals 0 divided by 5, let's say. That would be any number in which the numerator is 0 and the denominator is a number other than 0, then it's 0. So that's what it would work out to be, where if you use the slope formula, you'd have a 0 in the numerator, a number other than 0 in the denominator. The slope is 0. And that's what they're saying here. And of a vertical line, if you did the slope of a vertical line, you took 2 points, one there, put it in the slope formula, it would end up maybe 3/0. I'm just making this up. It's not necessarily this line. But here, the denominator would be a 0, and the numerator would be a number other than 0. This is the slope of a vertical line, and that is undefined. So what is the slope of every vertical line? It is undefined. This is what the graph looks like. It's going through the x-intercept. For this one, it's going through the y-intercept. All right, let's go on. And here is formula 2. It's called the slope-intercept form. Remember, chapter 2 is a review chapter, bringing in to mind what you've done previously, hopefully. Now, taking a look at the various slopes. So when you look at a graph and the line is starting low at the left and going upwards, this is positive slope. Slope is increasing. As you look at a graph and from the left to the right, the line is going down, this would be negative slope. If you have a horizontal line, that is 0 slope. And if you have a vertical line, that's undefined. Also, keep reading your textbook. Lots of good stuff there. This is just a summary. Also, if you have questions, ask your instructors. They are another key source for information in MathLab. Okay, another thing, and I'll pause. I didn't want to overload you on that first set of formula, but here are some others. Number 7, here's one slope and it equals the other slope. But the y-intercepts are not equal. Then the lines are going to be parallel. So you'll see this in a typical graph. I'll just sketch this. I didn't do that too well, but these lines are parallel. They'll have the same slope, but the intercepts will be different. These lines are parallel. Now here, if you look at the slope of one equation, and you look at the slope of the other, and you multiply the slopes, and the product of the slopes is a -1, then an example is 1/2 times a -2 over 1. The 2's cancel out, and you're just left with a -1. If this was the slope of the first equation, the slope of the second equation, these lines are perpendicular. And it would look like this. That, let's say this is the first line, and then this is the second line. And where they meet, they form a right angle. Okay, so the slope of one line is what we say the negative reciprocal of the other. So reciprocals, you recall, get a +1, but in this case they're going to be unlike signs. And don't make the mistake if they give you 1/3 is the slope of one and the other one is a -1/3. Are they reciprocals? No, these are opposites. That's going to give you a 0. And the product of those will give you a -1/9. That's a very common, tricky one they give. Okay, let's go on. How are we doing for time? 23 minutes. All right, this was another formula. I had left this one blank also. This is called the point slope form of the linear equations. Now suppose you know one point. There's one ordered pair. And you know the slope. You could put it in this formula and actually develop an equation. That equation could be in Formula 1, which is standard form, or Formula 2, depending what they're asking you for. So this would be the equation you would use. And I'm assuming you're going to get some examples on this here in your work. So here we're saying if x equals a, that is a formula for the vertical line with the x-intercept at a. Here they're using the letter k for a constant. Again, different textbooks do things a little differently. If I were to write the textbook, I would use a. Okay, so here are some of the equations we mentioned at the very beginning. And again, you can pause the tape or look at the PowerPoint to include this in your notes. This is the formula of a vertical line. Slope is undefined. This is the formula. You see they're using K here twice. So if you use the letter A there, that's better. And use the letter B, that's better. That's the y-intercept. This is the x-intercept. And there's the slope-intercept form, point-slope form, and then we said this is the general or standard form. See here they've used lowercase letters A's and B's, but again, different books. Okay, now they're going to give us, in fact, I think what I'll do is stop it here, and we'll have 2 videos on this section.